guys. Okay, so today we're gonna be able to basically learn how to draw Lewis dot structures. So that is our main focus, is the structures of it. So okay, so basically we have to go back to Lewis dot, the Lewis dot. Well, what is the Lewis dot? How do you get the Lewis dot? So the Lewis dot, you get it by this numbers. The Lewis dot is based on the valence electrons. Okay, so you're gonna draw a dot based on how many valence electrons it has in that atom. So it's quite simple. It just goes from left to right, and you just skip the transition metals. Okay, so you're gonna start here with hydrogen on the top being 1, beryllium on the top is 2. So all of these have 1 valence electrons. This group has 2 valence electrons, and then this was 3, 4, 5, 6, 7, 8. Now there is an exception to the rule, and it's helium. Helium has 2 valence electrons. Okay, so basically we talked about this, I believe, 2 days ago. And but I am going to refresh your mind on Lewis dot. So say for example, let's take bromine, and let's how many valence electrons does bromine have? So obviously it's 7. So it is 7. So now let's go ahead and draw just the Lewis dot by itself, bromine. So if we draw bromine, we write the symbol, and then we draw seven dots. Think of it as like a square, okay? And this is 12, 3 o'clock, 6 o'clock, 9 o'clock, if you guys remember. So, and then you go by singles first, and then you pair them up, okay? So the most it can take on each side is 2 valence electrons. So since this one has 7, we're going to go ahead and get started. So it will be 1, 2, 3, 4, 5, 6, 7. Okay, so without the box, it would just be like this, and this is how it's written. The box is just to help you understand for each side. Okay, so it would just be just like you see it on the left side. Okay, so again, that's just the Lewis dot with the valence electrons. Okay, so now we're gonna go ahead and see some examples and look at the terminology. So what we're going to be doing with the Lewis dot diagram, the diagrams, the structures we're going to start with covalent bonding. Okay, so covalent bonding or molecular is based on the video that I gave you yesterday to do as your assignment. So all it is basically it's basically a non-metal bonding with a non-metal. So all your non-metals are in here, are in this side of the table. The only non-metal that is on the left side is hydrogen. Okay, so it's hydrogen and all these. So mainly these non-metals is just bonding with another non-metal. They're together. Okay. So in here, make sure you write down this note. So covalent bonding or molecular, it's basically what happens is that these shares its valence electrons. To satisfy the octet rule. And we're going to talk about octet rule in a little bit. Or there's 2 of them that we're going to be looking at, hydrogen and helium, that follow the duet rule. Okay, the duet. Now these are just hydrogen and helium, and all the other nonmetals follow the octet rule. Okay, so what it is with covalent bonding is, keep in mind that it's non-metals bonding with non-metals. Okay, so and basically they do share their valence electrons, and we're gonna see that in a little bit. They do share it, and again, it's non-metals with non-metals. That's very, very important. Now, the octet rule, all it says is that when they bond, octet rule, for bonding, it needs to satisfy the atoms with 8 valence electrons. For duet is for duet rule, hydrogen, it's only for hydrogen and helium. And helium, remember, doesn't even bond, so it's like really out of the question. Really, it's hydrogen, okay? They're satisfied with 2 valence electron, and helium already has 2, so it doesn't even really, the rule doesn't even apply to it because it doesn't bond. It already has a 2, so it's already satisfied with 2 valence electrons. Okay, so that's important. Keep in mind, octet means like octopus, like 8 arms. Okay, duet means 2. Okay, and that's only for hydrogen. Okay, so now let's get to the practice. So let's look at the rules, and hopefully you guys understand it. Okay, so the steps for drawing the Lewis structures or diagrams. You need to count the valence electrons. After that, you need to look at all the atoms and decide, which is the atom that's going to be in the center. So you're going to be looking at that, and you have to look at the one that is the most single, the one that is 1. It's only one of them. That's the one that usually goes in the center, unless it's a hydrogen. If it's hydrogen, then hydrogens never go in the center. They always go outside. Okay. Worst case scenario is the lowest electronegativity. Most of them are going to be either one of these, but if worst case scenario, lowest electron, all you have to do is look at the periodic table, and the one with the left side. Since we're looking at non-metals, if you're looking at, say, carbon, nitrogen, and oxygen, say those 3, and you're trying to put them together. So the one that's going to go center is the one that way on the left. So it will be carbon, the one that will go in the middle. And now if you're looking at all 3, okay? After that, you draw a single bond to the central of the atom, okay? And I'm going to show you how to do the single bonds. And then you put all the remaining valence electrons. So you have so many electrons those electrons are the ones that make single bonds. So you're going to have to subtract, and whatever is left over, you're going to put them around the other atoms, okay? And then those that are not paired up, you decide if you need to do a double or triple bond, so it could satisfy that octet or duet rule. So that's important, okay? So I'm going to show you all these steps, okay? So let's start with something easy. We'll start with hydrogen. So hydrogen is like this. So let's start with H2. Okay, now this is a subscript. All it means is 2 of the H's. That means 2 hydrogens. So we have to draw each hydrogen. First, you draw it out. Hydrogen, hydrogen. Draw the Lewis dot. Okay? And then how many does it have? It has 1 valence electron. So you draw 1 and you draw 1. Now I'm going to go ahead and put this in purple, so you can know the difference. Okay? So now, total valence electrons. So now we're going to do the first step. First, we need to count all the dots. Okay? So how many dots do we have? We have a total total of 2 valence electrons. So in the end, they have to be a total of 2 dots whenever we're bonding. Okay, now these are not bonding yet. Okay, second step. The second step says determine the central atom. Well, this one, it's only 2 of them. So really, there's no central atom. Okay, so here, really, they're just going to be next to each other. So we're just going to draw them next to each other. Okay, and then the third step is draw a single bond to the central atom. So you're going to obviously put this dot in the middle and this dot in the middle. So you're going to put this dot and then that dot. So it goes to the center because the only way you bond them is by them connecting with 2 dots, with 2 valence electrons. Okay, so really you already use your 2 valence electrons, so it's already 2 total. It is following the duet rule. Why? Because if you think of it like a Venn diagram, and I put this in orange. So like here, this H has this 2. So it's following the duet rule. So duet rule means 2 valence electrons for hydrogen. Remember, hydrogen is exception. Okay? And then this hydrogen, the purple one, has 2. They share it. They share. Remember that sharing is covalent bonding. This is covalent bonding. Okay, it's non-metal plus non-metal. So these guys here on the right side, they're always about sharing. They love sharing. Okay, so non-metals with non-metals, because this is non-metal, that's a non-metal. Okay, they're sharing. Okay, so again, think of it as a Venn diagram, and a Venn diagram, whatever is similar, you put them in here. Okay, so anyways, let's do another example. Okay, our next example is going to be H2O. So H2O is water. So that means it's 2 hydrogens. And then it's going to be 1 oxygen, right? Because that's 2 and that's 1 oxygen. Remember, this little subscript belongs to this. Okay? So I should put that one in purple. H2O. Okay, and this is just 1, just because there's no little number, that it really just basically represents that 1. Okay, because that O is right there, so that means it's 1. Okay, so now I know you know that hydrogen has 1 valence electron, so 1 dot, 1 dot. Okay, and then oxygen has 6 valence electrons, so let's draw them. 1, 2, 3, 4, 5, 6. You see that? And you can tell right away, look, you see, so you don't even need the steps. Really, you don't. Right off the bat, you're going to know, oh, this one is 2. So hydrogen just needs 2, and then that will share it to, and that will make it all 8. So you know right off the bat, just by looking at it visually, where it's going to connect. Okay? But for the sake of the rules, I'm going to follow the rules so I could model for you just in case you get a really crazy, difficult one that you want to challenge yourself to do, then you do it the rules of steps. Okay? So let's go ahead and count all the valence electrons. So it will be 6. This is 6, 7, 8. So it's a total of 8 valence electrons. Okay? So the one that is determine the central atom, so the one that is by itself, the hydrogen has 2, so this is the only one that has 1. So oxygen will go in the middle. So it's going to go in the middle, oxygen. And so obviously hydrogens are going to be on the side. So it doesn't matter which side, it really doesn't. So here I'll just put it on this side, I'll put this one on the bottom. Okay? And then the third step is draw single bonds to the central atom. So I'm going to go ahead and get one from the oxygen, one from the hydrogen, one from the oxygen, and one from the hydrogen. You just need to know that there's two dots. You need two dots to bond them. Okay, you cannot have one dot in there. You need two dots, and that's it. Okay, to bond them. So you already used 4 dots from this 8. So it's -4. That means you need 4 more valence electrons. So obviously those 4 are not going to go in the hydrogen because hydrogen already has 2. And it only follows a duet rule. It won't do more than 2 for them. Okay, so the other 4 will go in the oxygen. So it will be 1, 2, 3, 4. Okay, and that will be it. Okay, now another way that you've probably seen in your medicine cabinet, you've probably seen, or you've seen water. You've seen it. Now I'm going to use just one color so you guys could see. Now there's another way to write it. Instead of putting all those dots, you could also do it like this: oxygen, hydrogen, hydrogen. But instead of 2 dots, you know, a little bit of more advanced chemistry, they put a line. That line means 2 dots. Okay, it's just a little shortcut that we like to use. We just know that that line means 2 dots. And then another line goes 2 dots. Okay, and sometimes you'll see it. Again, in your medicine cabinet, you might even see the molecular structure of it. So, and sometimes they draw the dots and sometimes they don't. They just know they don't need those dots because this ain't gonna react with anything else unless you break the bonds. Okay, unless you do a chemical reaction and you break the bonds. Okay, so that's for H2O. So you could write it either or. I'll accept any. Just a little bit advanced would be this one. Okay. Okay, so let's do one that is a little bit more advanced. This was hard. Now, I gave you your assignment. Your assignment does not consist it to be that difficult. There are like maybe 2 or 3 challenging ones, but you have 13 to select and you only pick 6. Okay, so you pick whatever you want. Whatever is your challenge you want to do, it's up to you. Okay, so now let's start with, now I'm going to give you a difficult one. Remember, the majority of your assignment is not this difficult. Okay, it's going to be the easy ones. Okay, so let's do sulfur trioxide. So sulfur trioxide. Okay, and I'll go ahead and use oxygen as 3. Okay, so now we're going to go ahead and draw them out. So sulfur is just how many? Just 1. It's just 1 sulfur. And then it has 3 oxygens. 1, 2, 3. Okay, so sulfur has 6 valence electrons. So it's 1, 2, 3, 4, 5, 6. And oxygen has 6 as well. So it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There you go. Okay, so now you count all your valence electrons. 6 times 4. That means it's a total of 24 valence electrons. Total. Okay, now step number 2. You count all your valence. That's step 1. Now determine the central atom. So this is your central atom since it's only a single element by itself. So that will go in the middle. I start putting the single paper in the middle of the paper. Okay, and then draw single bonds to the central atom. So what you're going to do is you're going to draw the rest of the O's around it. So it doesn't matter. You could go up, 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 or in the bottom. It doesn't matter. Okay, as long as it goes on any of the 4 sides. Okay, so I'm going to go ahead and put oxygen here, one of them, and then another one here, and I'm going to put another one here. Okay, so you need, so according to step 3, you got to bond them, right? So I'm going to go ahead and I'll just keep them brown. I'll keep them brown. Actually, I might just use all 6 of sulfur. So there you go. Okay, so again, you can adjust it however you want. So that will be the 6. So minus 6. So now you use 6 of the 24. So 24 minus 6, that will be, now you have 18 valence electrons to work with. Okay, so if you really think about it, it's really just around the oxygen. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So there, all your 24 valence electrons are there. Now the last step, you gotta check for duet, the octet rule. Now none of them follow the duet rule, so all of them, like sulfur, H oxygen, all of them have to follow 8. So we cover this right here, and I'm gonna put it in orange. You see this oxygen has 8. This oxygen has 8, so far so good. This oxygen has 8. Oh, wait a minute. This sulfur only has 6. So it's 1, 2, 3, 4, 5, 6. So one of the pairs from any oxygen, it doesn't matter. Okay? It doesn't matter. It's just by chance. It's really by chance what electrons are going to go, but they have to go 2. 2 up right away will fly over there to sulfur. Okay, so 2 of them, so let's say because I have more space here, so I'm going to move these 2 in the center, so my sulfur could have 8. So if you think about it, this oxygen, this sulfur will be sharing 4 of them, and this is sharing 2, and that's 2. So in the end, it should be 8 for both of them. Okay, so you see this oxygen will have 1, 2, 3, 4, 5, 6, 7, 8. This ones are no longer there because they flew over here. And this sulfur now has 1, 2, 3, 4, 5, 6, 7, 8. So let's rewrite this prettier. Okay, this will have sulfur. Okay, and then I'm going to have my oxygens. Now I'm going to go ahead and shift it here like a T. I'm just going to shift it. Well, no, I don't want to confuse y'all. So let me just keep it the same. It will be oxygen, oxygen, and oxygen. Okay. So in here, in this one, I'm going to go ahead and put the bonds in red. So this is one single bond. So I'm going to go ahead and put one line. One single bond, one line. That's 2, 4. And this has 2 double bonds, so it would be 2 lines. Okay, and then the rest, you could just put it there. So this one has 6. 1, 2, 3, 4, 5, 6. This one has 6 around it. And this one has only 4. Okay, so your answer should be this. Okay, that should be your answer. Okay, so that one again is one of the difficult ones. Okay, so again, keep in mind that each line represents 2 dots. One way to remember is like that, but this one's shifted. But one way to is connect the dots. Okay, and basically that's really it. So your assignment is online. It's in Schoology. So you're going to have an assignment. You have 13 problems. You're going to put it in a piece of paper, take a picture, and upload the picture in Schoology. Okay? So again, you have 13 problems, and you're just going to do 6 for practice. Okay, so make sure you have something with you, periodic table, so you could look at it and then see how many valence electrons it has. But other than that, we're pretty much done.